Hey guys, Rith here. Was working on this concept of in thermodynamics. So the main thing is I found when you go negative, so like this is a table, the Molia chart. So this upper part, can't find my mouse. So from here, this section here, this is the normal Molia chart. So I had a theory. I'm trying to extend it. Extending it on the positive side yields rather an exponential value, so it will roughly go for a while, but this point and this point might end up meeting. So for the Molia charts, these lines represent your pressure. So this is that can't find the focus, but it's okay. This line represents 30 bars, and here this end it's 0.0 it's at 0.0 let me just expand this. So it's from 30,000 bars to 0.008 bars. So these are these lines going in this direction. And then for the quality, 98% is here. Above this line is 100%. You have full steam, no water. And then it goes down in steps of 2 roughly. So you get 40% at this line. So I was trying to derive trying to see how low it will go. So I went to this point is 20, and then 18, and then 16, and then at this point is 14%. So roughly near zero, the convergence of this line, cause pressure quality does not pass this line. See, all these lines lead up to roughly this line here. So you extend that line coming down, and then you extend the lowest pressure that you can roughly achieve, and then you extend the highest pressure that you can roughly achieve. So this is this line. This line here represents high pressure. This line here represents low pressure, roughly zero bars. So this line here all the way up. So for quality, when you extend this line, it comes intercepts at this point. So this point will be roughly at 0%, and then coming this way. So coming to derive the percentage in this lower end, this is 100 degrees, so at 100 degrees is roughly where you get 14% of quality. 0 degrees you are below this intercept, because temperature are these lines. So this is 300, this is 400, this is 500, 600, 7, 8, 9, 1000, 11, and 1100 degrees. That's where roughly the molar chart that I have reaches. I'll extend this upper part to see where we will reach. So there is temperature for these lines, this going like this. There is pressure for this line, and then there's density. So this is the density going like this. The density follows the pressure bars, roughly the pressure bars, because from PVT, pressure times volume over temperature equals to a constant. So PVT equals to PVT. I hope you know the equation. So from there, this is the equation. So this is the equation: pressure times volume over temperature equals to K. So you find that when you change pressure, volume and temperature will change with respect to the pressure, and when you change volume, it will change with respect to pressure and volume, and when you change temp, it will change with respect to pressure and volume, following the equation. So this is times, this is divide. For MATLAB, the dot means you do it for each and every value. Fit it. So from there, you get so we are here. So this is 300, this is 300. We go to 200 at this line, 100 at this line, 0 at this line, negative 100 at this line, negative 200 at this line, and then negative 270 at this line. So this is roughly absolute zero. But when you fully extend the molar chart, the absolute zero should be roughly at negative 670 degrees Celsius. This is at this point, because this line, you have seen, this line is for quality, this line is for pressure. So this is at zero pressure. So when you extend at absolute zero, the negative 270, when you extend the line and follow this concept of pressure dropping, I mean temperature dropping, you'll find yourself at negative 670 degrees Celsius, and then the quality will be at negative 147%. So for quality, the default was I was using negative 273 for 100%. So I divided this section from this point to this point equally. So there are 5, so it's in steps of 20. So you get to at absolute zero, you'll roughly have negative 70% quality, and this quality is not for heat, it's now ice. It's converted back to solid, so it's 70% solid, 30% fluid, and then 100% is at temperature. This is negative 200, this is negative 300, at negative 400. So this is negative 500, this is negative 600, and then at this point is negative 670. Let me draw this up. I put the labels for these temperatures. So I've labeled them. So this is 300, 400, negative 500, negative 600, and negative 670. So and when you extend this line further, I haven't fully completed it, the same line for negative 270, and then you're at 30,000 bars. So this line, you'll find your temperature will drop further. Let me plot that. I come back. So from this point, I've tried extending the line further. So originally I thought it will reach at negative 670 because it was intercepting with the quality line, but you see we are having let's see, so this quality will go infinitely. Let's plot that. So going with the quality, give me a minute. So continuing, I roughly find that the temperature goes hand in hand with the quality. So the quality up to the point that my comp can plot, because I've tried extending it to the max, it's at 190%, negative 190%. So roughly from this point to this point you have full quality ice. At absolute, what roughly we estimate as absolute zero, it will be at 70% ice. And then these are your temperatures. So at 30,000 bars, your temperature should be at roughly negative 1900 degrees, negative 1900 degrees Celsius. Steps of 9, sorry, this should be 90. Let me correct that. So yeah, it's roughly at 1070, negative 1070 degrees Celsius. For extending, that's just extending the absolute to zero on this line. So there's roughly no absolute zero. Best option is just to go with degrees Celsius because kelvins will go to the negative side. Yeah, so this is a complete graph. Okay, not complete graph. We find that again going to the negative, it goes exponentially. It will expand from this point to this point, and that's roughly to infinite. And for high steam, it's the same, infinite. So there's like this is like a bulging, and this for 30,000 degrees. I mean, this for 30,000 bars, this for 0 bars. So if you have higher pressure, it will expand this way. And then the other thing is, this is the line for quality, and then it's the same line for bars. So as I explained, I extended this point for quality. I find that we are at negative 170 175 bars. That's cause when you extend this line up to here, we find that it's roughly at from 200 to 150 bars. So you extend it, it will be at this point, the crossover, the other part will be negative 175. That's from 150 to 200, but now on the negative side because it has flipped. So your enthalpy will be at negative 1800. For entropy, it will depend with what you're plotting. For negative 270, what you call it, from absolute zero. If you go to the actual zero that you can achieve from that pressure at 30,000 bars, it's negative 1070. So at negative 1070 is roughly negative 22 to 1070, it's roughly at negative 21 entropy, and entropy is kilojoules per kg Kelvin, and then enthalpy is kilojoules per kg. So yeah, that's it. Thanks for watching. Please do share, like, and subscribe. Thank you.